For a long time, the expectation seemed simple. As more observations arrived, the universe should become easier to understand. Predictions would get sharper. Uncertainty would shrink. Then the measurements started coming in. In 1998, astronomers tracked distant exploding stars and compared what they saw to what they expected. The pattern should have shown cosmic expansion gradually slowing down. Instead, the stars appeared farther away than they were supposed to be. The result repeated itself. Again and again, the observations refused to return to the prediction. Something was moving in the wrong direction. What looked like a routine effort to measure the universe suddenly changed into something far larger. Expansion was not slowing down. It was accelerating. That shift immediately altered the meaning of distance. A larger universe was one problem. A universe where separation keeps increasing faster over time is another. The assumption that better observations would steadily reveal more of reality could no longer survive unchanged. Because if expansion keeps accelerating, the challenge is no longer just reaching distant places. It is whether their information can keep reaching us at all. The obvious solution was technology. If distant galaxies are becoming harder to study, build larger telescopes, collect more light, improve the instruments, wait longer, look deeper. That approach had worked before, but accelerating expansion introduces a different kind of loss. Imagine a distant galaxy continuing exactly as before. Stars form, stars explode. New events unfold. Light leaves that galaxy and begins crossing space. Yet over time, more and more of that new information fails to reach us. The galaxy has not vanished. Nothing blocks the signal. Nothing destroys the events themselves. The problem is that the separation keeps increasing. The result is subtle at first. The galaxy is still there. Astronomers can still photograph it. They can still see where it is. What they stop receiving is its newer history. New events continue happening. The updates simply never arrive. Then the realization becomes difficult to ignore. Future astronomers may possess instruments far beyond anything available today, and still be unable to recover information that never arrived in the first place. The missing knowledge is not waiting for a better camera. It is already beyond reach. That breaks one of the oldest assumptions in science. The future is supposed to reveal more of reality, not hide parts of it. Yet accelerating expansion creates regions where lost information can never be recovered. And if enough of the observable universe slips into that category, the practice of observation itself begins to change. At first, the situation does not seem hopeless. Even if more distant regions drift beyond the reach of new observations, not everything is carried away. Some galaxies remain together. Over immense stretches of time, the Milky Way and nearby galaxies move under their shared gravity, drawing closer instead of separating. The night sky changes. Distinct galaxies approach. Structures overlap. Eventually, what were once neighboring systems become part of a single, larger, gravitationally bound environment. The result is important. Stars still exist. Planets still exist. Galaxies still exist. Future astronomers are not left staring into darkness. They still have stars to measure, galaxies to map, histories to reconstruct. The sky still appears full of answers. From inside that surviving local system, the universe may still appear rich with information. In fact, It is easy to imagine a future observer looking across countless stars and concluding that enough clues remain to piece together the larger picture. After all, science has always worked with incomplete records. Missing pieces do not automatically make a mystery unsolvable. And if an entire collection of galaxies survives close enough to remain visible, perhaps the situation is not as severe as it first appeared. Perhaps the essential clues are still there. Perhaps the larger story can still be recovered. The confidence does not survive. At first, the local system still appears rich with information. Stars move, galaxies remain visible, records of cosmic history seem preserved. Then the larger universe begins to fade from the picture. More distant galaxies slip beyond view. One by one, the observable population shrinks. Future astronomers look outward and find fewer external systems available for comparison. The sky does not suddenly go dark. It becomes quieter. The loss accumulates. A galaxy that once contributed evidence is no longer part of the observable record. Then another. Then another. The map keeps losing pieces while the observers stay exactly where they are. At the same time, another source of evidence weakens. A faint signal that once filled the universe becomes increasingly difficult to detect. Instruments search for it. The signal remains beyond reach. More sensitive equipment changes nothing. Eventually, it becomes effectively invisible to observation. That disappearance matters because the missing evidence is not secondary. These were some of the strongest observable clues that the universe was expanding and that it had evolved from a very different earlier state. Now those clues are no longer available. The local stars remain. The local galaxies remain. Entire generations of scientists can still conduct astronomy. But the evidence that revealed the larger cosmic story gradually leaves the observational record. And that is where the earlier confidence breaks. Future scientists may inherit a universe that still contains structure, motion, and complexity, while lacking the very observations that once allowed humanity to uncover its true history. The universe remains. The evidence does not. The conclusion is not that future civilizations become less intelligent. The conclusion is that they may inherit a different sky. Right now, multiple lines of evidence remain visible at the same time. Distant galaxies can still be observed. The expansion of the universe can still be measured. Ancient relic radiation can still be detected. Those observations overlap. Together, they reveal a history that would be difficult to uncover from any one piece alone. That overlap is the rare condition. As time passes, parts of that evidence disappear from observation. The local universe remains. Stars continue burning. Planets continue orbiting. Scientific tools continue improving. Knowledge advances. Technology advances. Civilizations may become far more capable than humanity is today. Yet, some of the observations that allowed humanity to discover the larger history of the universe are available only during this particular era. The evidence exists now because the universe still presents it. That will not always be true. The result is a surprising reversal of a familiar assumption. Scientific knowledge does not always accumulate in a straight line through time. Certain discoveries depend on when an observer exists, not only on how advanced that observer becomes. Humanity happens to live during the brief period when the critical clues are still visible together. Future civilizations may surpass us in almost every way. They may build better instruments, better observatories, better science, Yet the universe they inherit may contain fewer clues about its own past. They may know more than we do and still possess less evidence about the universe than we do today.